Hi folks, we're going to take a look at question 12 from page 120. So the first part of the question asks us to find the family of quartics with zeros 3 of order 2 and these zeros -4 plus root 3 and -4 minus root 3. So it's an interesting question because it's the first time we're coming across x-intercepts that are not rational numbers, okay, because of that square root of 3. However, we're going to solve this problem exactly like we would solve any other. Okay, so when we're writing a family of polynomials, we know that we can have different constant terms that are multiplying our factors, so we'll call that k. And because we have a 0 of 3, we know that we need a binomial x minus 3, okay, and because it's of order 2, that needs to be squared. Okay, now we have to use our two zeros given by -4 plus and minus root 3. So this is where we have to be a little careful with the algebra. So let's remember what one of our rules tells us. It says if x naught is a 0, okay, I guess we should put a 0, okay, then x minus x naught is a factor of the polynomial. Okay, x minus x naught represents the x-intercept. So this is where we have to be careful. The x-intercept is -4 plus root 3. So in order to do the algebra correctly, we're going to put that number in brackets. So it's x minus, and the 0 is -4 plus root 3. Okay, if you don't put the bracket, you will make sign errors. Okay, same thing with the third 0 there. It's x minus, and in bracket I'm going to put -4 minus root 3. Okay, it's because the whole number needs to be subtracted. Okay, and of course we're not going to leave it like this. We're going to simplify that. So we have k times x minus 3 squared, and then here we have x that becomes plus 4 minus root 3. Okay, and then this becomes x plus 4 again, but plus root 3 when we distribute that -1. Okay, and there we have it. We have our quartic, because here you've got an x squared and multiplying two x's, so it is a quartic, and it has the zeros given, but it's a family of polynomials because k can take on any number. Now technically we should, if we really want to be careful, we should specify that k can't be equal to 0, because then that just gives us the function y equals 0, which doesn't fit the bill for what we're looking for. Okay, so that's A. Now in B, they're asking us to find a particular member of that family. Okay, and they're telling us that 1, -22 is on the function. Okay, so that means it passes through that point. So we know that whenever x is equal to 1, y is equal to -22. So we'll input that into the equation and we can solve for one specific k. Okay, so -22 is equal to k times 1 minus 3 squared times 1 plus 4 minus root 3 times 1 plus 4 plus root 3. Okay, and let's start simplifying so we can solve. Okay, so here we have -2, but it's squared, so +4. Okay, and then here we've got 5 minus root 3, and there we've got 5 plus root 3. Okay, and this is where you have to now remember how to operate with expressions that have roots in them. So we could distribute this like a binomial, but I'm hoping that you notice that this is going to end up giving us a difference of squares because of the 5 minus root 3, then 5 plus root 3. Okay, so this 4k, and then here, what is this going to give us? Well, the first squared, so 5 squared, 25, minus root 3 squared, so minus 3. And so we're left with -22 equals, so that's 22 times 4, 88k, and k, well, that ends up being pretty easy because 22 over 88 is just 1/4, so -1/4. So the particular member of that family that also satisfies the condition of going through 1, -22 is given by -1/4. What do we have? X minus 3 squared x plus 4 minus root 3 times x plus 4 plus root 3. Okay? And certainly you can plug this into Desmos to see that it does give you the correct answer. Okay? So I'm just going to pan down on the solution. So here's the solution for A, and here's the solution for B. Okay, that's it for this one.